Good morning, my name is Chamu Kang. In this video, I will present my final project with the title of Development of a Kinect-based vision system with a human gesture recognition algorithm. First of all, we look at the problem statement in this project. Traditionally, gesture recognition requires high-quality stereoscopic cameras and complicated computer vision to monitor and analyze the human body movement in real time. Therefore, the cost of the system development for the various applications always turn out to be extensive and require extensive setup. Certain limitations on 2D image gesture detection includes inconsistent and inaccurate of the depth data from user detection and security tracking. Besides, most of the motion sensors must be attached on the human body for the motion tracking, and it may cause the uncomfortable experience of the user. The objective of this project is to develop a vision system for human gesture recognition and skeleton joint tracking with Kinect sensor. Secondly is to investigate and verify the detection of the user using the Kinect-based vision system. And thirdly is to analyze the user skeleton joint data from the user recognition with the Microsoft Kinect sensor. For the methodology of this project, so we look at the project flowchart. This project starts from the background of project, problem statement, objective, and literature review. After that, determine the hardware and software requirement for the system. The hardware include the Microsoft Kinect for Xbox 360 sensor and a computer. Software include the Microsoft Visual Studio, Kinect Software Developer Toolkit, and Kinect Studio. And the programming required for the software development is the C# language. So after we have all of the requirement, we proceed to the operator setup and software installation. Then the recognition of the human skeleton frame will be activated on the user interface. So we can observe and test on the human skeleton joint tracking algorithm. Lastly, proceed to the depth data analysis from the human gesture and analyze the result and validity of the vision system. So in terms of hardware, we have the computer or laptop that use as a platform for the software development and interaction between the human and the sensor. The Kinect sensor is used to detect the human motion and create a physical image on the interface. In terms of software, Microsoft Visual Studio has an integrated development environment for software application development. Kinect Studio used to allow the developer for recording, playback, and debug clips of user interacting with the application. Then the Kinect SDK allows the developers to build the application in programming language such as C++, C#, or Visual Basic with the Microsoft Visual Studio software. So next, we look at the operator setup and software development. The structure of the vision system starts from the connection between the Kinect sensor and the laptop, then run the software and then develop in the Visual Studio, and the human will be positioned in front of the sensor for the skeleton joint detection and recognition. As we can see from the flowchart, the tracking algorithm starts from the Kinect sensor installation in software development. Once the user interface appears on the screen, the RGB and depth image stream will be generated at the same time. Then the human skeleton joint will be detected from the depth image stream and the depth data of the skeleton joint will be estimated. After that, both depth and RGB color image stream work together to create the overlaid color frame with skeletal data of the human bodies on the screen of the user interface. And this is the part of the C# coding used for the RGB color and depth image stream. Next, this is the initialization from the Kinect-based vision system. Firstly, connect the Kinect sensor to the laptop by USB. Run the program that developed in the Visual Studio. Adjust the tilt angle of the Kinect sensor. Position the user in front of the sensor for user recognition and skeleton joint tracking. And once the operation done, close the application software and disconnect the sensor from the laptop. So from the result and discussion, we can see that there are 5 sections in the user interface, including the user image stream viewer, coordinate calculation viewer, Kinect tilt angle adjustment, selection of user bugs for detection, information, detection message. So after this demo video of this project will be shown. So in this project, I have carried out the user analysis for justification of accuracy and consistency on the user depth data. Therefore, two different postures of the user has been used to carry out the analysis. After this, the demo video for both user posture will be shown for the result analysis. So this is the posture 1. And this is the posture 2. The error and relative error calculation are applied for determining the accuracy and consistency of the depth data. So as you can see from the figure, the actual depth value is taken from both manual depth reading with measuring tape and system interface depth reading. And the experiment depth value is only taken from the system interface depth readings. As your information, I have taken the average value from 3 frequent experimental depth reading and compare it to the actual reading. Then apply the equations to get the error and relative error. So look at the depth data of the user right arm on the posture 1. We focus the higher percent error, which is 35 and 30% on the right wrist and right shoulder on the x-axis, and 14% on the y-axis of the right elbow. After that, I figure the detection will be unstable when there is overlapping of the user's skeleton joints. The sensor will have the difficult to track the skeleton joint, so sometimes the depth data will be inaccurate. For the second posture, we can see that the overall of the depth data has a lower percent error compared to the posture 1. So it has a good accuracy and stable detection from the sensor. As the conclusion, the Kinect sensor has been utilized for the development of a vision system for human recognition in the skeleton joint tracking algorithm in this project due to its affordable price and good accuracy on object detection. The skeleton joint tracking algorithm enables the recognition of a human skeleton frame on the application interface and depth data stream with the development of a C# language application program in Visual Studio software. However, the objective has been achieved by recognition of the human skeleton frame and depth data stream on the user interface. So several experimental depth data were taken for the result analysis. And based on the result analysis, it showed that the inconsistent and inaccurate of the depth data when there is overlapping of the joints during the skeleton joint tracking operation. So lastly, we look at the future recommendation from this project. As part of the transition to Industry 4.0, vision system is the collection of the technology that provide the machine with a better understanding of the environment. The Kinect-based vision system has the potential to be integrated with a wide range of the future work, such as human behavior assessment, gesture recognizing investigation, indoor 3D mapping, automation control, and other applications in a range of aspects. It can be applied in various fields, including the robotic automation, healthcare monitoring, education, and art. For example, it can help to provide the real-time control on the robotic automation and without the physical contact so that to reduce the risk of injuries and improve the performance efficiency. So that's all from me for my final year project presentations video. So thank you for listening.